Hi folks, today we're going to talk about cube root transformations. So we just finished talking about transforming the cubic parent function, but today we're going to talk about all the same kinds of transformations just with the cube root parent function. Remember that the cube root parent function still has points at -1, -1, 0, 0, and 1, 1, but instead of starting from the bottom left kind of down here and going up to the top right, it starts way over to the bottom left over here and goes to the top right. But we still have these three main points, -1, -1, 0, 0, and 1, 1. So some things to remember from the last video, from the last lesson, was that anything inside parentheses was a horizontal change and it was a lie. So if you have anything inside the parentheses, whatever it looks like it's doing, you need to do the opposite. If you have any changes outside of the parentheses, well then those are going to reflect, I should say reflect, those are going to show vertical changes. Something else that you might want to recall from the last lesson is that this right here, oops, this right here is kind of the general format for showing these transformations, but this is the more specific equation. So what I'm going to ask you to do in some of these problems today, just like in the previous lesson, I'm going to ask you to take the general form and move it into the equation form. So remembering that instead of cubing things, we're cube rooting things. So anything that is inside parentheses, so inside parentheses, you want to cube root it. And anything outside parentheses, you want to write before or after the cube root. Okay, so just some helpful hints from the last lesson. We start out talking about translations. Translations mean shifting, shifts that are happening. If you have a shift that's happening inside of parentheses, that's a horizontal shift, so it's going to move left and right. Remembering that any horizontal change is also a lie. So if you have a minus a number, that shifts to the right, and plus a number shifts to the left. Now if you have a plus or minus number outside of either parentheses or outside of your cube root, well then that's going to be a vertical change. So plus a number shifts up, minus a number shifts down. So let's look at example 1. I'll try and keep that up on the screen so that you can see it. Let's look at example 1a. It says write the equation of each transformed cube root function. Well, before I do that, it might be a good idea to show my parent function. 6, 7, 8, 5, 6, 7, 8. There we go. So this is what my parent function looks like. And we need to figure out the difference between the parent function and this function. So where did it move? Well, we want to count from the vertex and see where the vertex moved. It was here, but it's then been shifted down 1, 2 units. So if it's shifted down 2 units, that means that we're going to subtract 2 outside. And that's really the only thing that's happened here. It's still going in the same direction as the parent function. It didn't shift to the left or to the right. And then in the last set of notes, we reviewed how you can tell if there's a vertical stretch or compression. And it was if you move 1 unit to the right, you should be moving 1 unit up. Now we'll talk about that a little bit more in a little while, but just notice that 1 unit to the right and 1 unit up lands you back on your graph, so there's no extra transformations that are happening. I'm going to put in my cube root of x because that is my parent function, but I do subtract 2 because that's the transformation that's happening. My domain and my range used to be all real numbers because you couldn't put a boundary on the left or the right or the bottom or the top. And the same situation applies here. To our new graph, I can't put a boundary on the left or right, so the domain is all real numbers. And I can't put a boundary on the bottom or the top because there are arrows, so the range is also all real numbers. So what I'd like for you to do is, using the information in the notes and in example 1a, I'd like for you to try example 1b, perhaps graphing the parent function first, maybe including your domain and your range before you do anything else, and then deciding on what transformations are happening. So pause your video and try this problem. So after graphing your parent function, you'll see that your vertex moves from the origin over 1, 2, 3 to the left, so we should have x plus 3 under the radical. There's no other changes that happen. It doesn't shift up or down or stretch or compress in any direction. There's no reflection. Everything is kind of oriented the same way, and the domain and range are still all real numbers. No change there. So let's move to the second page. Second page starts out by talking about reflections that we discussed in the last class. If you have a reflection with a negative that is outside of the parentheses or outside of the radical, well, outside means vertical. So if I have some kind of graph, let's say the cubic parent function, or sorry, the cube root parent function, and if I am reflecting vertically, then that means that I'm taking this and putting it up here and this and putting it down here. That's a reflection over the x-axis. If I have a negative inside of parentheses, well, that means it's a horizontal reflection. So if I take my cube root parent function and I reflect horizontally, what that means is that anything on the right is going to the left and anything to the left is going to the right. That's over the y-axis. So those are my reflections. Let's combine those two bits of information and talk about translations and reflections together. So in example 2, graph each transformed cubic function, give the domain and the range. So I notice that I've got a negative outside. A negative outside means there's a reflection and it's over the x-axis. I also notice that inside of the radical I have a -2. That's a translation, that's a shift. And instead of going in the -2 direction, I'm going to go to the right 2. Because everything in parentheses is a lie. And there aren't any restricted domains, so my domain and my range will still be all real numbers. So let's transform this. My parent function looks like this. And I'd like to do some shifting. So I'm going to shift to the right. I always do my horizontal changes first. So I'm going to shift to the right 2. So from here I'm going to go over 1, 2. And then I'm going to reflect over the x-axis. So a point that was up here will now go down here. This point will stay the same, and a point that was down here will now go up here. So I have this situation going on and this situation going on. So this is my new graph. I'd like for you to pause your video and try example 2b, realizing that you should graph your parent function, write your domain and range, and then graph the two transformations that are happening. Try it out. So our domain and range are still all real numbers because there was no restriction on the domain. I have a y-axis reflection because the negative is happening inside of the radical, inside parentheses, and I'm shifting up 3. So I'm always going to do my horizontal changes first, anything inside the parentheses or under the radical, so I'm going to reflect over the y-axis. I took my pink parent function and I graphed new reflected points. And then every point I shifted up 3 units to create the blue graph that you see. Last question before the practice, last topic before the practice, we're going to discuss scale factor changes. So vertically stretching and compressing and horizontally stretching and compressing. We end up having those situations whenever we have a number that's out in front being multiplied or a number that's under the radical in front of x that's being multiplied. Basically, we're looking for coefficients. So typically, f of x would equal the cube root of x. But here I'm multiplying by 2. So I'm taking all of my original cube root values and I'm multiplying them by 2. When you multiply numbers by 2, what does that do to them? Make them bigger or smaller? That definitely makes them bigger, so I end up with bigger values. Oops. 2 times 0 is not 2, it's 0. And so whenever I plot my original parent function, it looks like this. But whenever I plot the new function, it looks like this. So negative 8, negative 4, negative 8, negative 4, negative 1, negative 2, 0, 0, 1, 2, and then 8, 4. So we can definitely tell that that has been pulled up and down because it gets much, much larger. So that would be a vertical stretch. What I'd like for you to do is, using that information, pause your video and try example 3b. So in this problem, 1/2 is being multiplied by your old y values. So we take the y values, multiply them by 1/2. That's going to change things vertically because the y values are the vertical component. So we're going to make all of our y values a little bit smaller. They all get closer to being kind of a flat line, and your blue curve right here is your transformed cube root function. That is definitely a vertical compression. So let's move to the last page. And because I'm working not on my computer, I have a 15-minute time limit, so we've only got about 3 minutes left. So I think what I'd like to do is I'd like you to turn the video on pause, try your problems, remembering what we did from the previous lesson, and then I'm going to do them too, and I'll put them back on the screen and I'll let you see the answers. So pause your video and try your problems. Okay, so once you have your problems done, you can check them here. Anything inside parentheses gets cube rooted. Anything outside goes in front or behind. So this is your equation. There's no negatives, so no reflection. There is a -4 under the radical, so we shift to the right 4. And there's a scale change of a vertical compression by a factor of 1/2 because we have a coefficient of 1/2 outside of the radical. So that's vertical, and it's a compression because it's between 0 and 1. The domain and the range remain all real numbers, just like they do in all of the problems because the domain's not restricted. In the next problem, there's nothing in the parentheses with x, so only x is being cube rooted. We've got a negative in the front and a +3 at the end. This negative in the front implies a reflection that's vertical. If I reflect vertically up and down, that's going to be over the x-axis. The translation is +3 outside, so vertically that's up, 3 units up. There's no coefficient other than the negative, and the domain and range are still all real numbers. Next question. The 2x + 1 gets cube rooted because it's inside parentheses. The -1 is at the end. We talked last lesson about not having anything, for us it was between the parenthesis and the x, but now it's between the cube root and the x. So I need to divide by whatever coefficient x has. If I divide by 2, then a 2 comes out. 2x over 2 becomes just an x, and 1 over 2 becomes 1/2. So that's going to change the translations that you might have thought were happening a little bit. There's still no leading coefficient that's negative, so no reflection. We're shifting to the left by 1/2 a unit, and we're shifting down 1 unit. This 2 right here inside the radical means there's a horizontal scale change. Oops, sorry. A horizontal scale change. Because it's a big number under the radical, that means that it's a lie, so it's not making things bigger, it's compressing them. And then you compress by the reciprocal, so the compression is by a factor of 1/2, and we're using the reciprocal because it's under the radical and that 2 is a lie. We don't have much time left, but this problem follows a similar pattern as the previous problem. You have to divide by -1 to get the true equation. This reflection is horizontal, so it's over the y-axis. It shifts to the right 1 and up 2, and there's no coefficient.